Okay, here we go, guys. The second in my writing linear equations video, and this one's going to be put in Algebra 2, although Algebra 1 students can do this as well, but it goes pretty quickly through parallel and perpendicular lines. So I'm going to run through a lot of problems, and we're going to start with this one here. The website for Veronica's Bakery states, you can read, but I'll go ahead and read it for you, that it will cost $65 to deliver 15 cupcakes and $200 to deliver 60 cupcakes. Write a linear equation in slope-intercept form to model the cost y and the number of cupcakes delivered x. Well, we'll get back to that. Let's take a look at how we would do this, and then we'll get back to it, okay? So, again, this is just a recap of how to write an equation of a line using my favorite point-slope form. Okay, so let's do this. Now, we need, we're going to use y minus y1 equals m times x minus x1. So my first point here is x1 and y1, and my second point is x2 and y2. Well, we need a slope and a point. Well, we got one, we got a point. We don't have a slope, so why don't we do that? Shall we? Remember that the slope is x2 minus x1. What am I doing? Say, stop me, maestros. That's not right. It's y2 minus y1 over x2 minus x1. So let's go ahead and do that. 11 minus 6 over negative 4 minus a negative 2. Okay, so 11 minus 6 is 5. And negative 4 minus negative 2 is negative 2. So we got negative 5 halves. What are you doing? Jeez. Negative 5 halves. Okay, so that's our slope, and we're going to plug it in now in our formula here. So y minus y1, which is 6, equals negative 5 halves times x minus x1, which was negative 2, so it's plus 2. And now we're going to simplify this, so we're going to distribute. Negative 5 halves x minus 5, and then add 6, and we get plus 6, and we're going to get plus 1. Alright, so there's our answer. Alright, let's take a look at another one, and hopefully you'll see if this is a practice. Not a practice. We can do it real quick though. We have an x-intercept and a y-intercept. So an x-intercept is 5, 0, right? And the y-intercept is a 0, whoa, that looks like a theta. It's theta. 0, negative 6. So we're going to use these as our x1, y1, x2, y2. Okay, so our slope is y2 minus y1. God, what are you doing? Can't write. Minus y1 over x2 minus x1. Okay, y2 is negative 6 minus 0. x2 is 0 minus 5. So we get negative 6 over negative 5, which is 6/5. Now, in the last video, I said if we have the y-intercept, we know that the y-intercept, man, this is the worst circling. B equals negative 6. Okay, if the y-intercept is negative 6, that's what B is. So we're gonna go straight to y equals mx plus b. I know some of you watch the other one, you're like, wait, Myos, you said that you don't need to do that. You should just go and use slope-intercept form, or point-slope form. And I'm saying back to you, I said, well, you know what? If you can go this way and go real quick, you might as well use this. I was only doing that so that you can get practice with point-slope form. So let's just go straight here. And then now you're saying, oh, okay, that's what I'll do then. All right, so let's look at the next one. Practice it. Practice it. I'll wait. Okay, I'm done waiting. Let's go. So this is x1, y1, x2, y2. Okay, so the slope is negative 4 minus 1 over 8 minus 6. And get negative 5 over 2. So now we're going to use our favorite formula. Y minus y1 equals m times x minus x1. Okay, so y minus y1, which was 1, equals m times x minus x1, which is 6. Y minus 1 equals negative 5 halves x, plus, see, 2 goes into 6 3 times. 3 times 20 is 15. Why is this? Slow down. I can't go that fast. Well, that's why you have a pause button, people. Okay? Pause it. All right. Let's go on. Write an equation, slope is their form. So we're going to use that guy again. There's so many problems. Oh my goodness, so many problems. If you guys can do this, you can probably, you know, if you feel good, you're like, yeah, I can do this. Go to the next problem. Just fast forward. Because the next problem is going to be with parallel lines. So you might as well, you know, take a chance. Whoa, what was going on there? Okay, negative 3 over 4. Y minus y1 equals m times x minus x1. Wow. You're like, Maestas, you've got fractions again. Please don't make us do fractions. Sorry guys, fractions are a part of life. Ha! Get it? A part of life because a fraction is a part? Ha! That makes myself laugh. Okay, 27 over 4. So we get y equals negative 3/4 x minus 36/4. Oh, I gotta. Okay, so let's y equals negative 3/4 minus 9 halves. There we go. Oop, forgot my x. Okay. Whew. Fractions. Let's get going here. Okay. Passes through negative 5 and parallel to the graph of this. So first thing we got to do is divide 3 over. So we get y equals 2/3 x minus 1. Now this is our slope because it's parallel, right? Don't forget that parallel lines have the same slope. So our slope is 2/3. This is our x1 and this is our y1. So we're going to use our favorite formula. Y minus, what are you doing? Y minus y1 equals m times x minus x1. So y minus y1, 5, equals m times x minus x1. Y minus 5 equals 2/3 x plus 8/3. Oh my gosh, Mr. Maestas, I have to do another one with fractions. Keep it calm, guys. Fractions aren't that bad, especially if you work with them so much. 23/3, okay? There we go. Alright, let's look at one more, and then my time is up with you guys. Perpendicular. Okay, so first we got to solve for y. Negative 5x plus 1. So my slope that's perpendicular is going to be the negative reciprocal, which is 1/5. Okay, so y minus y1 equals m times x minus x1. Let's go ahead and simplify this to slope-intercept form. 3/5. Man, I tell you, this thing cannot make 5s. Watch. Oh, of course. The time I say it, does it, huh? 1/5. See, look at that. Didn't do it again. Minus 13 over 5. Okay, so there's our answer. Alright, let's see if we have any more here. We do. It's a practice problem. We'll go ahead and crank through this guy too. x1, y1. Our slope is 3/2, so we get m equals 3/2. So we're going to go y minus y1 equals m times x minus x1. Do you like it that I sound so monotone while I do this problem? I sound like a robot teaching math. I know you don't want to hear that. Okay, so we just subtract here. Got our answer. Okay? Alright. So 3/2, we use the distributive property, okay? And then remember we multiply the top there, and then we just subtract 1. So back to this problem here. The website, Veronica states that it will cost $65 to deliver 15 cupcakes, $200 to deliver 60 cupcakes. So, write a linear equation in slope-intercept form to model the cost y to the number of cupcakes. So the cupcakes is our x. So 15 cupcakes and $65 is 1 point, and 60 cupcakes and $200 is another point. This is going to be x2, y2, and this is going to be x1, y1. Okay, so I'm going to find my slope by taking $200 minus $65 over $60 minus $15. They're not dollars, they're cupcakes. Sorry, cupcakes. So I'm going to have 135 divided by 45, which gives us 3. Okay, so we're going to use y minus y1 equals m times x minus x1. So y1 is $65, m is 3, x1 is 15 cupcakes. So let's go ahead and simplify this sucker. Okay, 45 because I used distributive property, add 65, and I get y equals 3x plus 20. Okay, and that's my model. All right, guys, that's it. Another one bites the dust. Talk to you later. Bye.